You would think that after being on YouTube for 4+ years and having, I don't know, a few hundred videos, that I could figure this stuff out and make an intro on my first try. And you know what's even worse is y'all would have been none the wiser had it not been for the shirt that I was wearing yesterday is in the washing machine. I think y'all would have noticed that I am wearing a different shirt than I am in the rest of the video. So, you know, full disclosure, that's what we're all about here. We show our mistakes. Anyway, I've got a couple of problems. I got a lot of problems, as you just witnessed. But one of them can be solved by CAD, and that's making a stand for this, which we'll talk about coming up in the video. My name's Scott. I'm 60 years old. I'm trying to learn CAD, and this is the Learning Curve 3D. Can you teach an old dog new tricks? And that's what we're here to find out. I'm the old dog, and the new trick is CAD and all this 3D printing. Hopefully by the end of this video, I will have a few tips to share with you on designing stuff in CAD and what mistakes not to make. As I am sure you will witness, the process that I do is quite scatterbrained, and it leads to a lot of mistakes. So, hey, I'm having fun with it. I hope you have fun with it watching me, and for those experienced CAD users out there that might be watching, I hope that I don't make you pull your hair out in frustration watching the stupid things I do. But that's what we're here for. If you want to learn CAD, I'm not going to teach you the right way to do it, but I'll show you a few ways of doing it the wrong way, and then we'll catch it later on and correct it. So, making mistakes is what it's all about. If you aren't screwing up, then you're probably not learning. All right, let's get into the video, and I hope you enjoy. This is the Water Warrior 5, made by Krieger Sluice. This is what I use to clean up my concentrates that I bring home from the river when I go gold panning. I have a whole bunch of these little containers that are full of dirt that we call concentrates. There's a bunch of them. So what I do when I'm out panning for gold is I pan off all the lightest junky material, and then I bring home the concentrated heavies that has the gold in it. The thought is if you process more material, you get more gold at the end of the day. So if you're wasting your time picking the gold out of the dirt on the river, then you're not processing material. So I bring it home and I like to run it through a cleanup sluice. However, problem number one is this sluice needs to be propped up, laid in at an angle of about 8 degrees. Let's just pretend that this is 8 degrees. If you're type A, then just go ahead and tilt your monitor or whatever you're watching this on, make it 8 degrees. So ideally, it should be propped up over the pan. This is the water catch pan. This catches the water and the dirt. There's a hole in the center, I don't know if you can see that, which drains down into another catch pan, and then there's a tub of water underneath this with a little pump. That's what this hose is for. So water's pumped up through, dirt's flushed out, the heavies settle in the bottom grooves, and I need a stand. Now, the fella that made the sluice also makes a stand for it. All well and good. However, this stand belongs in my backpack with this bigger sister or brother to this one. And I could buy another one of these, but where's the fun in that? I would much rather make my own. This is John's stand. This one will be ours, or mine. And it probably won't look like that. So let's go to the whiteboard and I will show you what I have in mind. And that leads to my biggest problem, getting what I have in my mind into CAD so I can get it on a 3D printer. Let me show you my idea. So I don't have a whiteboard, but I do have cardboard and a Sharpie. So this is what I'm thinking. If this is the end of the sluice, looking at it from the end, I want to make a piece That overlaps the top a little bit, comes down, straight across, up, and overlaps. Just cradles it. And then there'll be a threaded stud on each side. With another stand, or legs that come down and then flare out. Like that. And that's what it'll sit on. So if you were to look at this thing from the side, you would have, this is the cradle, and then you'd have a piece that sort of goes like this, and we'll put in some kind of a design holes or whatever in it, but anyway, and then there'll be something to clamp this down. So I want these legs to be able to pivot a little bit. So if I end up having to change pitch, then I can just loosen this nut, pivot the thing without these coming off the table on one end or the other. We'll be good. So I got to make one for the top and one for the bottom. The thickness of this is probably going to be the same thickness as this. I don't know what that is. I haven't measured it yet, but that's my idea. Hope that makes sense. It may make more sense when you start to see this thing come together. I have not designed any of it yet. So the first thing we're going to do is we're going to take some measurements, and we're going to just make a small piece that cradles this thing just to see and fit it up. And then we'll make the full size and try to add the threaded studs. I have been screwing around a little bit with making threaded things. Yeah, not very good at it. All the videos that I watch are equation-driven threads. So I think I found a little bit of a shortcut, and I'm going to cheat a little bit, but we'll cross that bridge when we get there. Let's make that cradle for this first and see how we do. That should be the easy part, but then again, when I'm learning CAD, nothing's ever easy. Okay, so here we are in the Libre, my CAD program of choice. Like I said before, I never seem to know what plane to start on, so we're just going to pick the one that's facing us. We're going to activate a sketch, and we're going to start right here at the origin, and I'm just going to draw some lines. So we're going to go out across, and then up, over, down, in, down, back across, and then we'll close it and escape. So from here we can assign dimensional values. So click dimension, and this is going to be 10 because the wall thickness is 5. So we want to go over the top of our wall 5 millimeters, and I want the overall thickness of my thing to be 5 millimeters. All right, so we're only making half of this, so the overall dimension on this thing is 128. So we can actually do 128 divided by 2, because a Libre will do some math for us, and boom, yowza, 619. That didn't come out right. 128 divided by 2, right? Ah, that looks better. 64. Goodness gracious. So let's do some more math. So this line should be 64 minus 5, right? So 59. And we want this line to be 5. And what did we say we wanted this one to be at? That's the inside. I think that's 89. And I believe this one needs to be 99. This should be 5. Yep. Perfect. And this should be 5. And that is 5. And I think we're good to go. So what we're going to do is we're going to close the sketch. And we're going to extrude that. And we're going to make that. What do you think? Do you think 20 millimeters is enough? So let's put 20 in there. And you know what? I'm going to edit that. And instead of to depth, I'm going to go mid-plane, because that'll put my extrude evenly on either side of that. And I think that'll help us later when we go to place the round piece on there for the stand. So that's half of it. So I think what we can do next is we can mirror this part. Features to mirror, we're going to pick the extrude, and the plane to mirror across, we're going to say that one. Yes sir, look at that. So there is our cradle. Now the only thing that I see that we got to add into there is a fillet. And I had fillet gauges somewhere, but I can't find them as usual. So let's just click that and we'll put something in there. We're going to give it an estimate of, like, we'll see what 10 looks like. Nope, that's too much. Let's do 5. I messed something up, didn't I? So we can go back and edit that. There we go. That looks better. And we'll put the same over there. And you know what? Just to make things look sort of nice, we'll fill it that edge and that edge to match. And maybe let's okay that. And let's do another fillet. Let's go up here and do just a small one, like 2.5. Oh yeah. That looks a little nicer. And I think the top of that thing is pretty sharp. Yep. I got it behind me. All right, so let's save this. We're going to call it the Krieger stand, because once we get it right, we'll just build on this and resave it. And then we're going to, let me make sure yep. So you always want to make sure that you're at the bottom of your tree, because if you're up here somewhere, it's not going to print everything. So you always got to make sure you're at the bottom of the tree. So we're going to export this. I'm going to export it as let's do a step file. I think step files are a tiny bit more accurate. Whatever that says, fine with me. So, okay, let's show you the workflow real quick on the Idea Maker. So this is the Idea Maker slicer. And you can see that it's like infinitely long for the belt. So what we'll do is we'll go import the Krieger stand and we'll open that up. Perfect. We're going to prototype this on the Idea Former belt printer. So we want to slice it. Click preview. And it doesn't look like there's any so what I think I'm going to do is I'm going to rotate that 180 degrees. And we'll slice it one more time. That'll give that front leading edge something to bond to the thing to. We'll give her another preview. So this is where we start. I don't see any floating areas. Perfect. So we'll export this Krieger stand. That is in the Idea Former slice files. Okay, so we come over to fluid. You can see the last thing I printed was a bin. If I go here to jobs, go to plus, go to upload files, brings me into the Idea Former slice files. EFGHIJK right there. It imports it. There it is. Click and print and clunk. All right. We have sent that to the printer. You know, just for giggles and grins, since I have another printer that's just sitting, we will bring that over to the A1. Perfecto. Look at that, 45 minutes. Red's in A1. Confirm it, send it, print it. That idea former starts really fast, so that's already printing. Okay, here's a prototype. First attempt, I screwed up the measurements. So, yeah. I got the outside measurements, and this should have been the outside measurement. So, back to the drawing board. Okay, well, we messed that measurement up. So we need to go back to it. See, this is the good thing about parametric drawing, because you can go back to your sketch, edit. So this measurement, 59, has to be the 180. That has to be 64. And then this one has to be 69. Right? Can we change that? Let's see if that 64 and 69. All right. So we're going to go back. Let's generate to bottom here. You know what? We're going to take this extrusion and we're going to go down to 10 millimeter. That will make it faster to print. So let's export that. There we go. Look at that, 28 minutes. Let's print that and see what it does. We're on red A1. There we go. Yeah, the cat's helping. So apart from the, that's the one that was printed on the A1. This was the one that was printed on the Idea Maker. So apart from, I guess it's on this side, right there, I made a little adjustment and it gave it a little layer shift. But other than that, I mean, that was my fault. This thing turned out really nice. That does print nice. But they're the wrong size, so the A1's printing another one. It'll be done in 20 minutes. Okay, here's our piece, and we're going to slide it on. It's already fitting better than it was. Oh. You know what? I think that'll do. Do I want it just a hair wider, like? No, I think that'll hold. That's actually fitting pretty good. All right, that's a keeper. Let's test print our next piece. Allow me to show you how I cheat on making threads. So this is McMaster Car. It's an online, like, industrial supply place where you can get just about anything you want. So let's go to threaded rods and threads. So what I did is I I picked some Acme rod, lead screws and nuts, and I found some Acme rod. I downloaded 1 by 10 thread, 1 inch by 10. So if you pick a 12-inch long rod, you can go over here and look at. They have 3D CAD files. They have them for SolidWorks, pair of solids. A lot of this stuff I don't even know what it is, but I just downloaded the step file. So after I saved it to my computer, I went back into Libre. So once I got to this point, I activated the sketch right on there. I took a center rectangle. Doesn't really matter as long as it's bigger. Deactivate and do an extrude cut. Now, on the extrude cut, I can do dual depth. So I can mess with this depth and not the other. So I just got it to where I wanted it, the lengthwise. And there I go. There's my stud. I'm going to X out of this and not save it because I already have a stud saved. Apparently I went like a 1 by 8 thread, not a 10. That looks a little more fine than what I downloaded. Stop. I got a cat bugging me here. No, we won't save changes. So the next step I did was I opened an assembly. Got into my Libre docs folder. There's the 1 inch. So I'll open both of those as an assembly. We'll finish it. We can move this over. We want it to get intersected in there. Let's get lined up here. Put it up here best you can in the center. Looks pretty good. Now I'm going to mirror this over. So I have to move a plane over to somewhere close in the center. That looked close. Okay, we'll hit our mirror, pick the plane, pick the part, hit OK. Oh, we're a little bit too far, so we'll Control Z that. We'll edit our plane. We'll bring it back roughly that far. I know this is highly scientific stuff right here. That looks pretty darn close. I think I'm going to go just a skosh the other way. Edit the plane again. We'll go 0.5 millimeter. We'll do a mirror, cross this plane, pick this part. Okay, boom, that looks good. Yeah. All right. Now what we can do is do an assembly boolean, and it should join all our parts together. I don't know what that means. And there we go. Now, the problem with this is, how do I print? Because no matter what orientation, I'm going to have supports. So what I am thinking is doing another extrude cut. I'm going to project I think I can do that. Oof. So I think we can just take a rectangle, right? Whoop. Let's escape out of that. You know what? Let's Control Z that. Can we? Let's try that again and go all the way over here. Nope, I messed that up again. Let's get down here. There we go. There we go. Whoop. Let's do a rectangle again down here. Guess it doesn't really matter. Deactivate the sketch. Do an extrude cut. Oh, wrong way. Reverse it. There we go. And we will OK that. And then we'll do the same thing on this side. We will activate the sketch. Okay. Now, is that enough to not need supports? But we can test print that. Okay, so I got this printed. And if you notice, I had to cut. You saw I cut the thing, because if I didn't, I would have needed some sort of support, and I don't want to support it. But apparently, screw up again. When I put these on, I put it on the wrong size saddle piece, so whatever you want to call this, bracket. Back to the drawing board. Now I got to take this. I don't know. I need a break. All right, so let's consult the cardboard while that piece is reprinting my screw up. So on this piece right here, the leg, we'll call it, I want to put a kind of a slot in here, and then my nut can screw down on there. So that's in case I need to move this piece up or down. I can run it in that slot to change my my angle of plus or minus 8 degrees. So this doesn't have to be very big. I don't think I need but maybe a couple of degrees, and that's not even an inch of travel. So that's going to be our next thing. What we're going to try to design are these legs here. So while that's printing, we'll go back on the computer. I've had a break, and we'll see if we can't make this work. See how many tries it takes. Okay, so I just swung some numbers at this thing and made this up. So we're going to prototype this. So it's the same thickness, 5 millimeters. It's 175 from here to here and 100 millimeters across, and the slot is that big. So I forget how that is. Anyway, we're just going to ship this off, print it real quick, and see what happens. That other piece fit on perfect. We'll go over there and take a look at it. I think I'm going to print this first, and then we'll go over and put the two pieces together and see where we're at. Okay, we made this prototype, this part. I think it came out pretty good, except for I think the slot is a little too big and the part overall is too high. So I think we're going to end the video here, because I think this is probably going to get pretty long if we keep going. So what's 3 things we learned from the 3 mistakes we made? Actually, I probably made more. But first one is take better measurements. This is the right one. So we changed our measurements and made the correction, prototyped one. So take better measurements. Have a better plan. That's probably the first thing we ought to say, because this is about 8 degrees, this pitch, and this is about where I want it as far as height goes off the table. I've got it propped up. However, I didn't take good measurements here. The next one is going to be, this is going to be a little smaller, the slot, and the overall height's going to be a little bit lower. And then mistake number 3, I didn't figure this out until later, is this. I made this nut when I was practicing. I had to increase the size of this nut on the X and the Y axis by 5%, so it's 105%. Z I left the same, but I had to make it a little bigger to make it thread on, otherwise it wouldn't. So what did we do when we made this? We put this where we wanted it, we moved our plane to the middle, and then we mirrored it over. Well, what happens when you mirror threads? It makes them the wrong stinking way. So these are what we'd consider left-hand threads now, and that's a right-hand threaded nut, so this isn't going to thread onto there. So I got to go back and change that. I can't mirror those over, not unless I make not unless I print off a left-hand threaded nut, which we can do because on McMaster-Carr they have a print for that, but I'm not going to do that. I'm going to go back and redo the thing. I think in the assembly I could import 2 of these, delete one, keep 2 of the threaded ones, and just move one over manually. We'll try that next, but that'll be for the next video. So we made some mistakes. Hopefully we've learned from them. Hopefully this will help you see that not everybody on YouTube is proficient in modeling or working with CAD. I certainly am not. So I hope this encourages you to don't worry about screwing up. You're going to waste a bunch of plastic. I have a crap ton of red, that's why I'm using it. Thanks for watching. We'll continue this in the next video. Don't be afraid to go design something. Make some mistakes. Y'all take care. We'll see you in the next video.